Hello everyone dear, welcome back to classes. This is teacher Shamira. So today we're going to be doing something very fun and exciting in our science lesson. But first, let us sing our good morning song. So let's start. Come on, sing along with me. Good morning, good morning. Good morning to you. Good morning, good morning. Good morning to you. Let's learn and play and have some fun being here today. Alright, so now let's sing it one more time, but this time I want you to sing it a little bit louder. Let's start. 1, 2, 3. Good morning, good morning. Good morning to you. Good morning, good morning. Good morning to you. Let's learn and play and have some fun being here today. Alright, so that was a very good morning. And how are you guys? I hope that you are doing good just as I am. Alright, so today we're all going to be scientists. And I want you first to cover your eyes. Place your hand in front of your eyes, and I want you to be as quiet as possible so that you can listen to everything that is happening around you. Pay very keen attention to every single thing. Do you hear that? That's a dog barking. Can you hear that? That's a bird chirping. Can you hear those people laughing? Who can tell me what all of these things are? These things are called songs. And songs are all around us. Every day we listen to different type of songs. It doesn't matter what produces the songs. Songs are made the same way through vibration. Can anyone tell me what is vibration? Very good. You're very smart. Vibration is the back and forth movement of an object. Songs are created when object vibrates and send waves of energy to our ears. Alright, so now that we know what sound is and what produces sound, we are going to talk a little bit more of different types of sound. But first, I want you to listen carefully to these two types of sounds. The first one here is a whistle. The other one is the roar of a lion. Listen to it very carefully. Let's listen to it one more time. Whistle, roar of a lion. What type of songs are you hearing? Alright, very good. You guys are very smart. You have your thinking cap today. When listening to the whistle, we can hear a high song. When listening to the roar of the lion, we can hear a low sound. And there's a special word that we use to tell when a sound is high or low. Can anyone give me the name of that special word? Excellent. That's called pitch. Pitch tells us when a song is high or low. And the words low and high are also known as high pitch and low pitch. I know that you might be wondering, what is high pitch or what is low pitch, or how are high or low pitch produced? Alright, today we're going to be scientists, and we are going to find out how high and low pitch are produced. And we are going to do a mini experiment, but first we need our materials. We need a balloon and we need a hex nut. If you don't have a hex nut, you can use a marble. Also, you need to have your observation sheet ready, the one that says my science experiment sheet. You need to have that ready so that you can record all the observations done from this experiment. So let's start with our experiment. You are going to place the hex nut inside the balloon. Make sure it enters in the balloon. I'll make it go down. Alright, then you're going to blow your balloon. Then you're going to tie your balloon And remember that sound is made through vibrations. And what does vibration mean? Vibration means the back and forth movement of something, right? So we are going to start moving our balloon. We're going to start moving it. Aha, do you hear that? That's a sound. So let's try it a little more faster, a little bit faster. Let's go slower. All right, what is it that you are observing? What is it that you observe when the balloon is moving faster? Very good. The pitch goes higher. Let's listen to it. High pitch. So if we move our balloon slower, the pitch goes slower. So this is how high pitch and low pitch are produced. If you move your balloon faster, when an object or the balloon vibrates fast, then you produce a higher pitch. If you move your balloon slower, then you produce a lower pitch. And this is how high and low pitch are produced. So now that we have learned how high and low pitch songs are made, we are going to listen to different songs, and we have to identify whether they have a high pitch or a low pitch. So I would want you to stand up if you're sitting down. When you identify this song, and if you think that it has a high pitch, you are going to stand tall and you are going to raise your hands reaching for the sky. And if you think that this song has a low pitch, then you are going to squat down. So the first song is the sound of a cow. Do you think that the sound of a cow is a high pitch or a low pitch? Tiptoe and reach for the sky if you think it is a high pitch, or squat down low if you think it is a low pitch. All right, very good. It is a low pitch. Let's listen to the second one. The laughter of a witch. Do you think it has a high pitch or a low pitch? Excellent. It has a high pitch. All right, so I hope that you enjoyed this lesson as much as I did. Remember to complete your record sheet, the one that says My Scientist Experiment, and you complete it, you take a picture of it, and you send it to me via WhatsApp.
Some produce waves of vibration. Low water produce fast vibration and high pitch.
Knock it down.
High water produce slow vibration and low pitch. My name is Michael Castro.
Good morning, Miss Cohen. Today we'll be talking about vibration. Vibration is back and forward movements. Fast vibration is high pitch sound. Low vibration is low pitch sound. Well, thank you for watching.
Hello, good morning. Welcome back to our science class. Today we're going to be learning about loudness of a sound. Let's move on to the other slide. I want to take a look at these scenarios, and I want you to observe at it carefully. What is happening in the first scenario? Very good. The little girl is whispering into the little boy's ear. Let's look at the second scenario. What do you think is happening there? Excellent. The boy is shouting. So in the first scenario, do you think that when the little girl whispered into the little boy's ear, this song was loud or soft? Excellent. It was soft because that when a person is whispering, you can barely hear what the person is saying, right? While on the other hand, when you hear someone shouting, the sound is what? Loud. You can hear the sound from far away. Alright, today we're going to be learning about loud or soft and quiet sounds. And the loud or soft and quiet sound is identified by its volume, which is another property of sound. Now, I want you to look at this video that I will put next, and I want you to observe and listen to the sounds carefully.
Hop Hop the Owl.
Quietly, quietly, very quietly, the snail is sleeping under the bushes. Loudly, loudly, very loudly, the noisy excavator digs and pushes. Shh! Be quiet, excavator. Quietly, quietly, very quietly, the boat is floating to the pole. Loudly, loudly, very loudly, I'm riding my bike even though I'm small. Shh! Be quiet, little bike. Quietly, quietly, very quietly, we build a tower blue and tall. Loudly, loudly, very loudly, we're crashing the tower with a yellow ball. Shh! Be quiet, Hop Hop.
Hop Hop, Peck Peck. Did you understand what is quiet and loud? How does a butterfly fly? Right, quietly. And the plane? Loudly. Peck Peck is playing drums very loudly. And Hop Hop is quietly hiding.
Alright, so I hope that you enjoyed this video. So I want you to identify 2 loud sounds and 2 quiet sounds shown in the video. And I want you to send your answer or your responses on WhatsApp using voice message, okay? Alright, let's move on to the other slide.
Hop Hop the Owl.
Alright, loud song has a high volume, while soft song has a low volume. For example, when you're listening to the radio and you hear your favorite song coming up, what's the first thing that you do? You go and you put all the volume because it's your favorite song, right? So therefore, this song is loud. While on the other hand, if you're watching a movie or watching your television and you have the volume low, you can barely hear what the person is saying in the movie or on the television, right? So loud song has a high volume and soft song has a low volume. These are examples of loud songs. Here we can see banging of a hammer. How many of you have seen this show Caso Cerrado with Dr. Ana Maria Polo? We would see her banging her hammer in court, right? So if you have not seen it, well, I am pretty sure that you know that this is used in a court. Alright, the banging of a hammer is loud, but the banging of a hammer doesn't have a high volume or a low volume key like with the TV and the radio. So how was the song produced? Well, let me explain it to you. Whenever you hit the hammer hard, it creates strong vibrations, and that strong vibrations form a big wave. And because it forms a big wave, that is why the sound is loud. So if you would hit that hammer, you would hit it softly, the vibration would be weak. Therefore, it would create a small wave, a small sound wave. And that is why the sound would be soft or quiet, right? Alright, so how many of you have heard the song of a ninja motorcycle? Oh my gosh, that is really, really loud. So loud songs, we have banging of hammer and ninja motorcycle. Now let's move on to soft sounds. Here in this first picture, we can see Santa walking tiptoe. And why do you think that Santa is walking tiptoe? Very good, because he doesn't want to wake up the little boy. He wants the little boy to wake up and have the gifts under his tree as a surprise. So when Santa tiptoes, that means that he is walking quietly, right? The second picture, we have wind blowing. The sound of wind blowing is a quiet or soft sound. While on the other hand, the thunder. Do you think that the thunder is a soft sound? No way. How many of you have jumped when you heard a thunder? Me. I have jumped many times because the thunder is very loud. Alright. Banging of a hammer and the song of a ninja motorcycle are examples of loud songs, while walking tiptoe and the song of blowing wind are examples of soft sound. Now, I am going to show you a small experiment that I did for you to understand how loud and soft songs are made. Pay very keen attention to it. Alright, so today we're going to be doing an experiment to find out the difference of loudness. So first of all, I am using a pot here and I place some water. You can use a steel cup if you have any at home. And I'm also going to be using a spoon to strike the water. Now what I want you to do is to observe the water while I strike it. I'm going to start striking the pot softly, and I want you to observe the water. You saw that wave there? A small little wave is formed. I'm going to start striking it a little harder. What do you notice? That the wave is bigger, right? I'm going to do it softly now. Small wave. Small wave. Big wave. Alright, so if you notice when I struck the pot softly, it created a small wave, right? This is because when I strike the pot, the vibration is weak, therefore it creates a small wave, and this is why the sound is produced softly. It is not loud enough. So if I strike the pot hard, look at it. You see the wave is bigger because when I strike the pot, the vibration is stronger, creating a bigger wave. Therefore, the song is louder. So in other words, the difference of loudness is due to the amplitude of waves. And amplitude means that, in simple terms, amplitude is just the size of the wave, the length and the width. Alright, I hope that you like this experiment, and remember that loudness depends on the amplitude of waves. And remember that the amplitude of waves is just the size of the wave, the width or the length. So remember that when I struck the pot hard, the wave was bigger and therefore it produced a louder sound. And when I struck the pot softly, the wave was small, so the sound was softer or quieter, right? Alright, loudness refers to how loud or soft a sound seems to a listener. The loudness of a sound is determined in turn by the intensity of the sound waves. The bigger the wave, the louder the sound. The smaller the wave, the quieter or softer the sound. Very good. So let's go over the vocabulary words here. Sound. Sound, it is a form of energy produced by vibrating bodies. Pitch, it tells how high or low sound is. High pitch, sounds made by fast vibration. Low pitch, sounds made by slow vibration. Volume, it tells how soft or loud a sound is. And vibration is the back and forth movement of an object. Alright, so now that you have learned that loudness is how loud or soft a sound is, and on the previous session we discussed about pitch, which tells us how high or loud a sound is, I want you to first of all use your instrument that you created on previous session and show me a loud and a soft sound using your recycled instrument. And I want you to record yourself explaining me in your own words what is the difference between pitch and loudness. Both of them will be recorded and you are going to send them to me via WhatsApp. I'm going to upload a rubric with further explanations of what I will be expecting on the video.
Okay, this is a loud sound and this is the soft sound. So, like when the little boy that on the picture, when the little boy screamed, it was hard. When the little girl was whispering, it was soft. So, this is louder and this is softer. That is the loud sound and the soft sound. Good afternoon, Miss. I will be explaining what is the difference between pitch and loudness. Pitch told you how high or a low sound is. Loudness told you how loud or soft a sound is.
Alright, I hope that you enjoyed this video. Have a good day. See you on the other class session.